In this video, we're going to talk about everything you need to know about the cross product in under 5 minutes. So we have these two vectors here, vector A with components A1, A2, and A3, and vector B with components B1, B2, B3. This is the formula for the cross product right here. You can see A cross B is equal to this I hat component, and then this J hat component, and this K hat component. And so the first thing to notice here is that the cross product of two vectors is itself going to be a vector, right? That's why we have these different components in the first place. A vector has a magnitude and a direction. This is the direction. This much in the I hat direction, this much in J hat, this much in K hat. And so if we want to do an example here, we have these two vectors. A is 5, 0, negative 2. B is 2, negative 4, negative 3. The first thing that we're going to do in solving this problem is not use this formula. Instead, what I like to use is the matrix determinant method for solving the cross product. And so essentially, we're just going to take the determinant using this setup here. So those two vectors, A cross B above, A cross B, are equal to this determinant, I hat, J hat, K hat, always go on the top row. And then we do the A vector components, so 5, 0, negative 2, B vector components 2, negative 4, negative 3. That is going to equal I hat, so we know that there's some I hat component, and rather than memorizing the formula above, we just use this determinant method. So block out the row and the column with I hat in it, and I just do it visually. I'm just drawing it to help show what's going on. So block out that row and that column, and then do this diagonal minus this diagonal. In other words, it's a 2 by 2 determinant right here. And so what does that mean here? Well, 0 times negative 3 is going to be 0 minus negative 4 times negative 2 is going to be positive 8. Then we're going to subtract the J hat component. So we always go positive I hat component, get those numbers. We do minus the J hat component, and then for minus the J hat, we're going to block out the row and column with J hat in it, and we're going to do again this 2 by 2 determinant, but instead we're multiplying 5 by negative 3 and subtracting negative 2 times 2. So 5 times negative 3 is negative 15. Subtracting negative 2 times 2 is going to be negative 4. All right, and then we can add the K hat component. The K hat component is going to be obtained using the exact same method. So we're going to block out the row and the column with K hat in it, and we're going to do this 2 by 2 determinant right here. So 5 times negative 4 minus 0 times 2 is going to be negative 20 minus 0. And so our vector A cross B, that resultant vector, I shouldn't say resultant, just that the vector that we get as an answer here is going to be negative 8 I hat. Negative 15 plus 4 is negative 11, but this negative from outside needs to distribute in. So we have positive 11 J hat, and then minus 20 K hat. And that's your answer. So there's your vector answer there. Now, quickly, we'll go over some properties. So it has an anti-commutative property, the cross product does. So A cross B is actually equal to negative B cross A. There's also a distributive property where if you're adding two vectors, B plus C, what you can do, if you're trying to take the cross product of that sum, you can do A cross B plus A cross C. So distribute it in. And there's also the scalar multiplication property. So essentially, if you have a scalar and you're multiplying it by this vector A, and then you're taking a cross product, it's the same thing as just taking the cross product first and then multiplying by the scalar. Or on the other hand, you could just multiply the second vector by the scalar and then take the cross product. Any of those ways work. And then finally here for the properties, the cross product of a vector with itself is the 0 vector. So A cross A, for example, is the 0 vector. So not just 0. Remember, the result needs to be a vector, so it's the 0 vector. Finally, geometric interpretation. The magnitude of the cross product, A cross B, is given by these, we denote that by these double bars. That's going to be the area of the parallelogram that has sides given by vector A and vector B. And then we can write this by this formula here, where that magnitude is equal to the magnitude of A times the magnitude of B times sine of theta, where theta is the angle between vector A and vector B.